Hello. The following example is example 4.1.9 in your notes. The rational function f of x equals 2x plus 3 all over x minus 4, where x is not equal to 4, is a one-to-one function, and we want to find its inverse. Now, here's the thing about this. We're actually being very nice here and saying that x is not equal to 4. I don't technically need that, because your denominator can never equal 0, which means x minus 4 is not equal to 0, which means x is not equal to 4. What that does is it tells me what my domain is. My domain is going to be in interval notation negative infinity to 4, union 4 to infinity. Notice though that I'm excluding the 4. In a little bit I'm going to want to figure out what the range is. I'll come back to that. Okay, what I want to do is I want to follow the steps for finding the inverse function of a one-to-one function. The first step is to replace f of x with y. So y is actually equal to 2x plus 3 all over x minus 4. And again, I like to draw a line. Everything from here on out will be the inverse function. Now replace all x's with y and all y's with x. So this y becomes x, and both of these x's become y's. So that gives me 2y plus 3 all over y minus 4. Now technically, in order to do what I'm about to do, I'm going to have to say that y minus 4 is not equal to 0, which means y is not equal to 4. So because of this, I can multiply both sides here by y minus 4. Whenever I do that, this y minus 4 and this y minus 4 cancel each other. And on the right hand side, you're simply left with 2y plus 3. At this point, distribute the x into both of these terms for the y minus 4. That actually gives me xy minus 4x. Now what I want to do is I want to get all y's on one side and everything else on the other. To do this, notice that there's already a y in this term, so it can stay where it is if I get everything to all y's to the left hand side. This x term, however, needs to go to the right hand side. Anytime you're moving terms from one side to the other, you need to either add or subtract. So you're going to add 4x to both sides here. Notice that the 4x's are gone on the left hand side. On the right hand side, I still have this 2y. I want that on the left hand side because that's where I want all my y terms. So I'm going to subtract 2y from both sides. Notice that that's gone. And this 3 can stay where it is because it does not have a y with it. So what you get from this is the fact that xy minus 2y is equal to 4x plus 3, or 3 plus 4x, whichever one you prefer. Now on the left hand side, notice there's a y here and a y here. There's a y in common. I'm going to factor that y out. Bear in mind, y will not always be the greatest common factor. In this case, yes it is, but it may not always be. But I don't care. The only thing I care about is getting that y by itself. So what happens is that gives me y times x minus 2 is equal to 4x plus 3. At this point I need to get the y by itself. This is y times something, so I'm going to divide to get rid of that multiplication. So the x minus 2's cancel, and on the left hand side I'm simply left with y equals 4x plus 3 all over x minus 2. Now always write that out as f inverse of x is equal to 4x plus 3 all over x minus 2. And there's your function. Now I want to be very careful here. What's the domain for this inverse function? Notice that my denominator here is x minus 2, and that means x minus 2 is not equal to 0. Because of that, that means that x is not equal to 2, and in interval notation that's negative infinity to 2 union 2 to infinity. And I also want to know what the range is. Now, what's great about this is because the x's became y and the y's became x, I know that this domain will have to become the range for my inverse function. So my range for my inverse function is actually negative infinity to 4 union 4 to infinity, because the x's from the original function became the y's for the inverse function. So if the domain was this, it became the range for the inverse function. And the reverse argument holds true as well. If this is the domain for the inverse function, that had to be the range for the original function. So the range for the original function has to be negative infinity to 2 union 2 to infinity.